be here. We have girls varsity and boys JV and varsity wrestling at Belfouche all day today and tomorrow.
Do the thing, I'm gonna go kill trees.
Juniors, your quotes are due today.
Have fun.
Daniel? Little, did them, see Mrs. Walters. Do you have any questions? And I believe Mrs. Walters is not here today. All students are welcome to Forum Fridays every Friday during lunch in the select first room. The presenter is Maya Harris. Forum Friday today during lunch. Sure you have your student IDs for snowball tomorrow night. The office is not free in the afternoon today. Sure you have your IDs. The last day to buy tickets if they're available. And look at the doors tomorrow night. If they did drama, support them Monday night, night of 1 act, 3 comedy, 1 act, beginning at 7 o'clock. Registration for next year's classes continues today. There's Spartan time for freshmen. Freshmen report to your Spartan time. Then come into the theater. Spartan time teachers kind of keep your groups spread from other groups so we can have them show you what they need to before they leave. That will all be explained once you're there. Sophomores, at the beginning of Spartan time today, you will take the pride survey. Those of you who have parent approval, Spartan time teachers have that list. Regular Spartan time other than that for all other people. If I participate in track, you should have contacted Coach Nida, especially if you're a pole vaulter. Pole vault practice starts on Monday. You need to see Mr. Nida today for information on that if you are interested in being a pole vault participant this year during the track season. Other track athletes that aren't in the winter sport, you'll start on February 27th. Those in the winter sport, we'll make arrangements to start after your basketball and wrestling season is complete. Young Life Dodgeball Tournament this weekend, Sunday at 101 in the gym. Still have time to register. You can do that through the QR code on the flyers hanging around the school and in the library. So please stand for the pledge. To the flag.
The United States of America, and to the republic for which it stands, one nation, under God, indivisible, liberty and justice.
All.
Looking straight up at it. It's so funny. Where?
You could survive.
Oh.
Cancer. Over.
Oh really? Oh really? Oh really? You wanna go there?
Yeah.
I see. That was a little appalled that you did indeed. You are? Honestly, good. Just there to attack up. I rest my case.
I'm so
tired.
Like, put it in the calculator.
Did you get like time to go? It's his name, Dave.
Well, I did it. Yeah, I'm not spent on it yet.
I thought it was multiple landmarks. see about it.
Y'all might get a flight today. Someone broke the copier. Yeah. It's because... Dang. Folks who struggle to follow basic directions... Ooh. Keep using the big copier when they're not supposed to. So, everyone got the thing done? Finishing up, pressing buttons. Everyone got a graphing calculator on hand for today. Or, for most of the stuff we're doing today, that 36X Pro, that black and silver calculator that I keep rambling about, it'll do most of what we're talking about today. So either a grapher or you got that on hand. See, I was hoping to do 08 and start into 11 today, but with the copier potentially destroyed, we don't have the Chapter 1 packets yet. So we might just get a chance to do a little bit of a deep dive on our prob stats that we did not get in Algebra 2, most of us. Actually, we get to have interesting conversations today about who in here is normal. All right. When we did our matrix ops yesterday, again, I didn't include this as the assignment because we all seemed fine with it, but I did include it up here because I want to make sure we still understand how basic operations work with matrices. I don't want to write out every step of this with matrices, so what should I do first? I'm going to solve that guy for x. First, add a, and then, careful on wording.
Divide 2 on both sides.
Multiply each side by 1/2.
Yes and yes, right? Because with matrices, there is no such thing as division, there is multiplication. So I am dividing by 2, but to write my operation, I'm going to call it 1/2 the quantity, a plus b. Now, you're still doing that by mental math, right? This plus this, divide by 2. This plus this, divide by 2. But just be careful that we don't actually divide with matrices. Like literally in that chapter, which we may or may not get to, when we divide matrices, we don't divide matrices. We only multiply by reciprocals and inverses. Like there is no such thing as division with matrices. So it sounds like we're arguing semantics, but it is actually whether you can or can't do it. Mental math, I'm guessing most of us are okay with that. I take -1 plus 5 is 4, half of that. 2 plus 0, half of that. -1, -1, half of that. 4 and 4, half of that. 2 and -6, half of that. 3 and 7, half of that. And you should be there. Cool? So it's just mental mojo. If all you have written is this and then the answer matrix, cool. Because that's how we were doing it yesterday. It's mostly mental math. I showed you how to do these in the calculators and said, isn't it 9 times out of 10 easier to just do the mental math instead of go through all the effort of typing it in? Then, the sheer irony that this was the problem today. We actually played this game last night in Game Club. It's Castle Panic. It's a co-op game. All the trolls and stuff are coming out of the forest at you, and you throw barbarians at them and stuff. It's great. There are 5 orcs, 4 trolls, 6 goblins in the surrounding forest. The Goblin King will send 10 of them at random to attack your castle. What is the probability? He sends 3 orcs, 3 trolls, 4 gobos. This is our combinatoric stuff that we were supposed to review yesterday, but may have just been introduced to. Hopefully you all wrote down that little cheater template for it. It's a combination of permutations, combinations, fundamental counting principle, and probability all smacked together in one problem. I write it out as, how many ways can I choose 3 of the 5 orcs? What is the mathematical way to do that? Well, first of all, does order matter? Does Grug going in front of Gonk make a difference? No. So it's combinations, and I'm going to say 5 combination 3. And then there's 4 trolls. Combination, I'm choosing 3 of them. There's 6 goblins. Combination, I'm choosing 4 of them. Grand total, how many critters are coming at you? 5, 4, 6. There's 15 total in the forest, and of those, 10 are coming at you. So that is the total possible ways that this, I don't know, kamikaze group can be selected. So you write them out like that and press the buttons. Do we have a group consensus on what that particular probability is? I heard 19.99. I heard about 20. Okay, 9.8. Okay, it depends how far you're going. Typically what we do is, if you haven't been in my room before, I have this kind of hard and fast rule about 3 decimal places. And my rule about 3 decimal places comes from kids in geometry who couldn't work with trigonometric expressions as they were doing formula work. Y'all remember like getting slant height we'll call what? Find the surface area of a right pentagonal pyramid.
Yeah, I can't say I remember that.
If there's 4 sides, just 2 squares and then another square.
Okay. We're going to have our 5 triangles off to the sides. We're going to have to find our slant height or slope height for the side lengths. To find the area of the base, you're going to have to do 1/2 ANS, apothem, number of sides, side length. And in order to do that, you had to right triangle trig that guy, because you would have 360 total degrees broken up into 5 sections, which is then broken up into double triangles. So this is 36 degrees, and you would have to use this side length right here is going to be tangent of x over 6 equals 30, tangent of 36 equals x over 36. So that side length is x tangent of 36. I had kids who could not work with that in geometry. For the life of them, putting 6 tangent of 36 in parentheses and then just working with that did not click. So I told them, just write the decimal out to 3 places and use that. Because it turns out, even when you started talking about really, really big figures, like we were finding surface area of the Great Pyramid of Giza. And they were gigantic, and if you go to the hundredths, your answer was off by like several hundred because of how big the numbers were. If you go to the tenths, you're off by like 1,000 something. You're not even in the right zip code. But if you went out to the thousandths, 3 places, it was pretty good. Okay, so this probability came out as 0.199 what? Okay.
800.
So if I saw 0.199800, I'm focusing on 3 decimal places.
I thought it was.
Was
Oh,
it?
it is 99.
Okay. So in that case, I would say that makes this go up, which domino affects into that, which domino affects into that. If you just said about 20%, I'm cool. If you said 19.98%, I'm cool. If you had a morning brain fart and said 19.9%, all right, fine. Okay? This is about the likelihood, and this may have also been the first time that you've done this for any form of academic credit or points in a class. So we've got a little bit of leeway there. All right? So if you said 19 and change, or you just rounded it up to 20, we're cool. Please tell me this looks kind of familiar. Okay. So I'm looking at, did you, question, thing. You performed your operations correctly, and then you got the mental math to get over here. So I'm just going to say 2 in general, where say you did everything right, but then over here you call it a positive 2 kind of business. Okay, 1 off. You just missed a negative. It happens. Down here, I want the setup, the correct numbers with each of the combinations, and that you used combination. We talked about whether order mattered or didn't. I'm going to assume if you did those 3 things correctly that your answer is correct. Okay, so the setup of this times this times this over thing. Even if you completely whiffed on everything after that, you understood I multiply together categories and then divide by total. Did you set them up as combinations? Did you put the numbers in the right spots? There were a few kids I saw yesterday, I don't remember which classes, I think it was both. There were a few kids I saw accidentally swapping the numbers on the combinations. I want you to think about what that really means. What if I swap this to 4 combination 6? What is that saying? There are 4 people at this table. How many ways can I make a group of 6? 0. Okay, and that's what it's going to do. It's going to say 0. Well, what happens if you accidentally swapped even one of these? And now you have 0, 0, 0 over number. It's going to say there's 0% chance. Or maybe you did it for all of them. Now it says 0, 0, 0 divided by 0. Now your calculator tells you, nah, like you can't do that. Okay, first commandment in domain, thou shalt not divide by 0. So 2 for first one, 3 for second one, something out of 5, and poke, poke, poke. There we go. The assignment, it was 4 problems, which was deceptive because those 4 problems had some ABCDEs with them. It was practice with probability, since it sounds like as a whole, most of us did not have the prob stats in Algebra 2 either at all or that we should have. And that's something that's going to happen, okay? For the next generation, basically, we are going to see little hiccups and gaps due to the disruption of the last 3 years. Okay, so, it's nothing anyone did wrong. It's just, the world imploded. So I put a little extra practice on this. I said that the solutions were in the Glencoe folder. I know several of you found them because people were texting me on Remind. Thank you. I want people asking questions. I know that some kids found the solutions and they were double checking things. Is there anything about those 4 that you would like to go through? Didn't quite make sense? One of them had a really, really good question about the phone number one, because they were confused about saying that there's this many digits, but then they say that there's 7 digits.
Yeah.
And that is a very real confusion, like very easy to make. They use the word digits in 2 different contexts. There's digits, the 7 spaces of the phone number, and then there's digits, the 10 numbers that you're using. And then they put them both in the same sentence. That is very understandable. That is confusing. For those of you that did this and you worked through everything, you're probably starting to recognize that most probability stuff isn't even about the math. It's about common sense. It's about logic. Okay. Some other stuff about probability. Textbook publishers and test designers are going to assume certain knowledge on the behalf of students. Does everyone know how many cards are in a standard deck of playing cards? Okay. How many face cards are there?
Four for each set. 12.
Wait, really?
12, right? Jack, Queen, King, 4 suits. Okay. How many number value cards are there?
Well, 10 for each. So 40. Just 40 minus.
And then you start arguing about the precept of the question.
Oh, it's not 40. It's because there's A.
Isn't it 36? Because ace may count as 1, but it's not a number. And did they mean to include that? Or were they very literal? Right? So things like that. If they ever say a standard number cube, they don't say a standard number cube, they say a die, and that's it. And as any nerd knows, there's a lot more than just a D6 for a type of die that you can have. One of my Game Club kids has a D100. I used to have one that was like inside a plastic ball and it was like water floating, kind of like an 8-ball. And then the little water dot at the top showed you which number it was. It was pretty cool. And then someone stole it. No, it got broke. Yeah, we were playing golf with it. Because it kind of looks like a golf ball. It's got 100 faces to it, right? It just looks like a golf ball. There's a whole bunch of little dimples to it. But there's all kinds of dice, playing cards. They'll assume basic knowledge, like, do you know how many weeks are in a year? 52, and sometimes it feels like we're on the 365th week of March 2020. There's how many days? 0.25. I even have the t-shirt that has the mathematical proof for why it's 365.25 on it. Okay. It's just okay, how do I know if it's a leap year or not?
If it's a multiple.
Yeah, how do I know if it's a leap year? Is this a leap year?
No. Is it a
Look at calendar.
Well, 2004
I heard
was
it.
Year, so if you just do
If it's divisible by 4. Okay? Because every 100 years, 100 is divisible by 4, right? So I only need to look at the last 2 digits. Since 23 is not divisible by 4, 2023 is not a leap year. All of this kind of random, almost trivia knowledge, they expect that you know this when you're doing probability and statistics. Okay? So, since we're not going to have the chapter 1 packets, if we have time after doing 08, I might break out some probability tree stuff that you didn't get in Algebra 2, if we got time. But everyone got their calculator out. Reset. Reset. Second plus 7, enter 2. Even if you don't remember all that, as long as you remember it's in second plus under memory. Under memory is reset, all RAM. Yeah, you're sure.
must have an interest here.
And again, remember, if you ever program something in your personal calculator, don't clear out all RAMs, clear out all values. Because if you clear all RAM and you actually programmed something into your calculator or you downloaded something, then that's gone too. All right, so just be careful if you have your own personal calculator as to what you're clearing out. I don't know how much I can assume about your knowledge of stats because we're kind of all over the place, right? Our sophomores who just came out of Algebra 2, I know that you maybe didn't get this at all. I know my classes, we didn't get to it. We had to cut it because of that snowmageddon that happened. What else? For those who did get to a little bit of prob stats, it sounded like there was only one or two. Yes, ma'am. Oh, yeah. There was, what was it? Did you get to, those of you who did get to prob stats, did you do standard deviation and normal curve?
We did do that a little bit.
We had like a day of probability and a day of stats.
So it was just kind of crammed in there and hey, here's a curve.
Yeah.
Okay. So that's the kind of stuff that we're going to review today. And we're going to find who has hyper-specific self-research knowledge in the topic. First up, measures of central tendency. Just listen to the words there. Measures, okay, number, measurement, gotcha. Central, what does that mean?
Center.
Somewhere in the middle, the center. We don't want to use a word to define the word, right? Tendency. What if I say that you have a tendency to over-caffeinate yourself in the morning and crash by 2? No! Why would you do that? You just set an alarm for 12:05 to remember that you always have to have your next dose of caffeine. Measures of central tendency is numbers that tell you ballpark where the group of data is. This is a good number that represents the data. For example, in here, what if I was talking about age of humans in the room? The three that you know from all the way back to elementary school is mean, median, and mode. You all know that mean is average. Add them up, divide by how many there are. Median. Whatever's in the middle, be careful. You can't just cross it out, 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 all the way to the middle. What do you have to do before that? Put them in order from least to greatest, and then you work your way to the middle. What happens if there isn't a number in the middle? What if there's 2? Find the average of that, the midpoint of that. Add them up, divide by 2. Mode, what's mode? Okay, most often. Something that might, I'm going to forget that every morning all semester. There is a little bit of symbology here that maybe we didn't see before. Have you ever seen mu? Okay.
Yeah. It's like one of those really tiny ones.
Okay, it is a lowercase Greek m. Mu. Okay? And you probably saw it in physical science to mean micro. Right? Micrometers, microliters. Okay? What it means here is the mean. We don't call it average, we call it mean. What we're usually going to see is X bar, and that is how you say it, X bar. X bar is the mean of the sample versus the population. We kind of talked about it yesterday. What's the difference between a sample and a population? Just knowing English.
Population is the total thing, and a sample is just a representative sample, a representative piece.
Right? Like population would be the whole high school. Sample would be everyone in this class and Mr. Lappy's in first hour. Like that would be a sample, right? It's a part of the whole. We're usually going to see sample because typically we don't have the entire population for data. We just have a part of it.
Is it like a representative sample? Is it random?
Ooh, now you're starting to get into sample bias. For our purposes, our sample will just be the data collected, but then you also get into how and when do you collect the data. That has sample bias. That's a whole different section. I hope we can get to it.
That's this class?
Should have been in Algebra 2. The short version is, y'all, numbers don't lie. People lie with numbers. Okay? Numbers don't lie, people lie with numbers. The simplest example of that I can show you is how many times have you watched TV and you see a commercial that's #1 truck in America? Don't they all say that?
Yeah.
But,
Get it.
and then in the fine itty bitty print that no one can see at the bottom, it's the difference between, is it the #1 in consumer satisfaction? Is it the #1 in sales in the continuous US? Is it #1 in customer retention? Is it #1 in the Kelley Blue Book resale value? Is it #1 in, like, there's all these things, right? They can say #1 and they ain't lying. It is. But they're lying with the numbers, or not maybe lying, but using it to misinform you. Okay, misinformation based off of statistics that can be created by bias is a real big thing in the last few years. Okay, there's a lot of medical organizations, nonprofits that are funded by billionaires that are using statistical practices to come up with something that looks legit. Bias is absolutely a factor in statistics. Think about if I was trying to say, what is your favorite kind of pizza? Where I collect that data matters, right? If I collect that data outside of Safeway, most people are probably going to assume that I'm talking about something inside. They're going to tell me different kinds of pizzas that you can bring home. So they're going to think about the different frozen pizzas. Versus if I go over a block, if I'm standing in the median in between Domino's and Little Caesars, and now I ask, what's your favorite kind of pizza? That's going to change the answers, right? Domino's tastes better, Little Caesars is cheaper, live on a budget, okay? So yes, bias absolutely affects your sample. We're going to do something super simple here where we're just going to collect data within the room, okay? Have you seen that guy before?
Yeah, but I don't know what it is.
Sigma, capital Greek S. Okay? And it means sum. Capital Greek S, sigma, means sum. So, x bar equals sigma x over n is the mean is, add them all up, divide by how many there are. You've known that since elementary school. It's just whether or not you've ever seen that symbol for it. Okay? Median and mode. Oh, next to mode. Let's write. You probably remember getting problems doing mean, median, mode all the way back to elementary, middle school, where you might have 4 or 5 different modes because everything happened 3 times. Statistically, we don't do that. Usually, you will have 1 mode. You might have 2, and it's literally called bimodal. or we'll say no mode. Because after two things occurring the most, they're just like, nah, there's no mode. Okay. That's usually what we do in statistics. Again, depending on which branch and which textbook, which publisher, which application you're in. My juniors, y'all done significant figures yet? Seniors, you know what I'm talking about. Significant figures, right?
I still don't know what was going on.
Significant figures is one of those things that everyone just,
I got there kind of by guessing.
there's kind of a collective hatred for them. Whether it's significant or not depends on the data set. Some data sets and applications, you might want to have 4 modes. But most of them are going to say no mode after 2. Okay? Now, talking about measures of central tendency. If measure of central tendency is a number that describes the data set, what if I was in here talking about age? Age of human in room. Mean, median, and mode. What do you think, just ballpark, the mean would be? The average age of a person in this room.
I'd say like 17 and a half because you are old.
That's just the running joke in game club. Like, I might as well be grandpa.
You're like 80, right?
I'm gonna ballpark that. Ow. My knees are. The rest of me isn't. Median though. Now what do you think?
Yeah, 16.
We got a bunch of sophomores in the room. I would say we're probably at 16. Mode will probably be 16 as well. Why are these two likely to be so different? Outlier, right? By the way, I'm 38. Okay.
You mean 83?
No. If I make it past 70, I'm just gonna old yeller myself behind the shed. Like my family, like my biological father and my grandfather both died of like different types of cancers. I've got Alzheimer's and dementia coming down the pipeline. Like, nah, dude, I don't want to go past 70. If at 38, I'm going to pull that average up a little bit. What happens when you get one of those substitutes in here who is about 80? Now everyone in here, by average, is legal drinking age. Like, it just, the mean can be thrown off by outliers, big time. But the median, what happens if I have a data set that's 16, 16, 16, 16, 16, 17, 17, 17, 17, 18, 125? Isn't the median still going to be 16? So which one is a better representative of the data set depends on whether we have outliers. And that's what I'd like you to write next to it. That if we have outliers, use median. Out. Thy ers. Li. Mean, I'm going to use if no outliers. Mode, hate to break it to you, after years of doing mean, median, and mode, no one really uses a mode. Like, we just don't use it. So, those are measures of central tendency, a number that describes the group. What would measure of spread be? What would measure of spread be?
The lowest and highest stars?
Okay, range is a good example of spread. The range of my data values. If I'm talking about the age of people in the room and I say, do we got any real youngins in here? We got any 15s? If we're going by maturity, we're going to have to go down to 12. Okay. Okay.
Boy Scout humor is like 11 year olds on average.
But if I'm talking about range of people, or if I said range of people in a typical high school math classroom, and then I said 15 to 38, you'd be like, you gonna miss class for jury duty? What? So you would have to understand that one of those is probably the teacher. The range would not be a good measure of spread for the data set. Instead, I would use stuff like variance and standard deviation. This is where we might be getting into new stuff for some of you. Okay, variance, be honest with you, variance is just used to find standard deviation. We don't really use it for anything else. But standard deviation itself, ooh yeah. Okay, standard deviation got a big honking formula. By show of hands, who knows what standard deviation is and you have found it before? Ouch. Okay.
We did it in chemistry a lot. Anyone that's listening
Okay.
did it like a lot.
All right. So, to show you what that is, if you got like a scrap sheet of paper, if you want to put it on a blank part of your packet, if, one of the pages in the back, if you got room, something, we're gonna detour here, and I'm gonna show you what standard deviation is.
I know. Because I got scared that it was going to be a voice. Like you. Who else is
I have reasons.
Why?
Pearson, Prob stats, all notes. There we go. Okay.
If we're doing a different subject, we just
I feel very
you're putting yourself further behind.
Yes.
Come on now.
I haven't had the time to do the work.
There we go.
Class period yet, so I'll be able to set up work next week easy, but you're gonna put yourself behind that.
All right. So, standard deviation is, see if we can break down the symbols here. What is this? What do I do? Sum, add them up. What is this? X bar is the mean. So you're going to take every value, subtract the mean, so you find the distance from the value to the mean. Sometimes, yeah, every value. That's why I'm adding them all up. Sometimes when I subtract the value minus the mean, I might get a negative number, right? Because the numbers can be on either side of the mean. That's why I'm squaring them, so I always end up with positives. I will add them all up and divide by how many there are. And because I squared a bunch of crap, I need to square root at the end to put it back where it's supposed to be. Standard deviation is, and if you want to write this wherever you're at, standard deviation is the average spread from the mean. Average spread or distance from the mean. And I'll just straight up tell you that what's considered a normal distribution, a standard deviation, is typically about 15% of mean. That would be normal. Okay? So if I have something smaller than that, say my standard deviation is like 3% of the mean, that is a hyper-specific, consistent set of data. But if I have standard deviation that's like 30% of the mean, that means my data is really spread out. Okay? This determines how spread out my data is, and it's the best version of how can I crunch numbers so they make sense and they're consistent and they're not thrown off by outliers and all that business. Standard deviation, because it squares and then square roots, because it adds up the average distance of everything. Standard deviation is, it compacts that data into, like, you seen the first Transformers? Like when Bumblebee comes up to the giant cube and it goes into this little box and then Sam runs around with it. That's what standard deviation does to data sets, is it takes all of your numbers and it compacts them into, here's my mean, here's how far away from my mean all of my data should be. And it allows me to determine what is and is not normal. We're going to find one of them by hand, just so you see what we're doing here. Here is a data set. Make a little table next to it for our data values. And yes, you are getting basically what was supposed to be in chapter 11 of Algebra 2. It's just the copier was busted, so we're taking a detour today. Write out your data values. I've got 6.9, 8.7, 7.6, 4.8, 9.0. It asks you to find X bar, the mean. How do I find the mean? Add them all up, divide by 5. Do it. So what's that? 14, 21, 3, 0, 3, 6, 4, 17, 17, 24, 28, 33, 5, 6.6, question mark? Hmm?
7.4.
Samsonite, way off. Okay, so next to each of those, I'm going to write 7.4. Because the mean is the mean, no matter what. Because column 2 says, find the distance between them. Take the value minus the mean. So you're going to find out how far away from the average all of my data points are. So if I take 6.9 minus 7.4, I got a negative 0.5. I get a positive 1.3, a positive 0.2, a negative, what's that, 0.6, 2.6? And a positive 1.6. So that's how far each of my data points is away from the average, from not the middle, but what should be roughly the middle, what should be roughly the center of my data. And then they say, square them. Because some of those are negative, I don't want negatives. I know a good way to make everything not negative is to square them. So, square them all. Square that. You'll get 0.25. Square that, 2.69. Square that, no, 1.69. Square that, 0.04. Square that, 2, 6, 400, 120, 120, 240, 640, 36, 676, 6.76. And 1.6 is 2.56. So column 1, here's my data. Column 2, here's my mean. Column 3, here's how far away from the mean all my data is. Column 4, I square it all so that I got positives. And now, add those up. So what's that, 12, 16, 25, 30, 3, 5, 11, 18, 23, 3, 2, 2, 3, 9, 11, 11.3. Okay.
Yep.
If I want the average of all those distances, I add them up and divide by, in this case, 5. So if I divide that by 5,
You get two,
Come on, Doyo.
2.26.
Yeah. Someone from this makes me want to cry.
Okay. And then, because I squared a bunch of stuff, now I need to square that, which is going to be awful close to 1.5.
Because 1.5 is 2.25.
So I get my standard deviation is about 1.5 what? Okay. Second negative. Okay. That was the entire process to find standard deviation of just 5 data points. I want you to think about the number of times you've had statistics stuff. Isn't it normally like 20, 30, 100,
900.
5,000 data points? Would you like to do standard deviation for that?
Yes.
Or, like Staples, we say, there's an app for that. Okay, I just wanted to show you, this is what it's doing in the background when you press the numbers. How do I put data into my calculator? Stat edit. Now we see who did lots of regression last year. Okay, or last semester. Go to stat edit. Type in your data points. What were they? I don't want to go back and forth between the things. 6.9, 8.7, 6. Okay, type in your data points. Now, in Algebra 2, you should have been over here quite a number of times because we did, remember, linear regression and quadratic regression, cubic, quartic. Later on, you did exponential. Well, I know my class didn't get to that. We didn't get to the models. But there's exponential and logarithmic regression. There's power regression, logistic regression. There's all kinds of fun stuff, right? Where do I calculate all that junk? Where do I calculate things from data? Stat over to calculate. Look at the very first thing. You will never find mean, median, mode, variance, standard deviation, quartiles, any of that by hand again. Which is the difference between Algebra 1 and Algebra 2, as we show you where this is. You're going to hit one variable stats. Make sure you say the correct list. Frequency list is when you have a lot of data. If I don't want to put in 16, 16, 16, 16, 16, 16, 16, I don't want to put in 50 16s. I'll just have 16 and then the list next to it, I'll say 50. Okay? We are not going to use a frequency list in here because we're not going to have data sets that big. So never worry about frequency list in here. Calculate. Boop, doop, 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 doop. Answer. Look at the very first thing.
Which one did you get?
Stat calculate one variable stats. Look at your mean, 7.4. It even has sigma x. It tells you what the sum of your values was. It tells you what that squared is. It tells you what your population and sample standard deviations are. Or sorry, sample and population. Tells you your number of values. Scroll on down. Does anyone remember seeing these before?
Yes.
Box and whisker plots. That's called your 5-number summary. Box and whisker plots are super easy because didn't I just put a bunch of data in to my stats? Stat plot, box and whisker plot. Bam, does it for you. Okay, so we're going to get to all of that in a minute. We're going to actually do all that. But this is how you do statistics in Algebra 2 and beyond. You don't hard crunch the numbers. You put the numbers in a calculator, press the button, and now you got to think. What does it mean? Because statistics is 50-50 number crunching versus logic. You have to understand what the data means. Okay, that is how we find data sets. I know all of this, and we're only on the first one because when they say find the measures of central tendency and spread, I don't want to use their data at all. I want to get a little personal. Oh yeah, everyone in here, got to say it loud and proud so everyone can hear you. Everyone follow along. Start with, we are not using this data, but we are going to write our answers here. We're going to find the measures of central tendency and spread for, let's start with ages. Okay? So, first things first, I just put data in there and I don't want it there anymore. 2 ways to do this, 3 maybe. Way number 1, if I just go stat edit and arrow up onto list 1, don't you dare hit delete. You will delete the list, it will just poof out, gone. Hit clear, enter. I can do it that way. Option 2, how many of you saw when you were doing second plus, look at one of the options under the memory menu. Clear all lists. Okay? So, stat edit. Let's put in, going around the room, starting with Lori. Let's get our ages in there. 15, she's a youngin'. 16. All of you should be typing this in. Okay, let's pause and make sure everyone's caught up. Stat, edit, 15, 16, 17. Okay, let's start here and ping pong our way back. 18. 16. 16. 16. Here's a youngin'. 16. We're going to see a lot of those. Okay, everyone, are we on? It says entry 12. Okay, just making sure that no one missed anything. All the way back there. What we got?
You.
17. 17. 17. And 17.
What about you?
Yeah.
I want to find it first and then put me in to see what it does to the stats. And then we're going to take me out of there and then we're going to put like one of our substitutes in there. See what that does to the stats.
The one that wears your pants
Okay.
up here and doesn't let you touch your smartphone.
All right. So we should have 17 numbers in there. It should now be on list entry 18. Has everyone got that? Okay, where do I find my one variable stats again? Stat, calculate my one variable stats. I do not need a frequency list because I didn't have a ridiculous amount of data. I just hit calculate. So over here, measures a central tendency. I'm going to say that my mean was about 16.412. Where's median? I don't see it. Scroll down. About where we expected it. Equals 16. Mode. Remember when I said we almost never use mode for anything in stats? It is so useless that they don't even put it on this list. You got to go look at your list. But what's it going to be? Okay. Now, we're talking about chronological age, not maturational. Now, we cut that like so, and we'll say what happens when we go stat edit, we go all the way down to the bottom, and we toss in 38. Now go calculate it and see what happens. Stat, calculate. Okay, so now entry 18. Papa Bear's 38. Oof. Well, the whole lot of you are now on average 17.6. Okay. But look at the median and the mode. Still 16. This is why we say if you know that there's outliers, don't use mean. Use median. A good example of that, if you ever listen to the news of any kind, sometimes you'll hear the difference between mean and median being used in their words. Like the mean or average home value in spearfish versus the median home value in spearfish. How would those two numbers be different? Or what about the average income of a person versus the median income of a person? Outliers. In the last 5 years, in the last 10, in the last 20, the rich have gotten richer, the poor have gotten poorer. During the year of 2022, when all of this inflation was happening, it wasn't inflation because of X, Y, and Z. The top companies across the stock market reported record-breaking profits. That's not inflation, that's price gouging. Okay? Do you know that when gas around here was up around $4.50, closing in on $5 a gallon, the price per barrel of crude oil was the exact same that it was 5 years ago, no problem. Okay? Outliers are going to affect things big time. What happens when I say the average home value in spearfish? Y'all know that it includes all the fancy pants up on the hill, right? It might as well be a mansion. Versus I say the median home value. Okay? Outliers really affect things. Let's see what happens to that exact same data set. Go stat, edit. Uh-oh, Sullivan's gone on Monday. There's a substitute in here. Maybe it's, what's his face that always rambles on about Germany.
Mr. Razor?
And he is about 78 years old. I'm just ballparking. Dude's wrinkly, I don't know. Go stat, calculate, and look at what happens to your one variable stats with one outlier that bad. Okay? That's the difference between outliers and not on a data set. Now, down here, measures a spread. Okay, let's yeet me and the substitute out of there. Let's go back to you guys. I wasn't on that one. I replaced me with substitute. Okay. Go back to stat edit, back to the bottom of the list, get me out of there, get the substitute out of there. Okay. Delete that entry. Again, you should be at 17 entries. 18 is where your cursor is on. Ready? Go back to your stat, calculate one variable stats. We're going to find the measures of spread as well. The first measure of spread was range. How do I find range? Okay, so scroll on down and let's take maximum minus minimum. What is the range of student ages in the room? Okay. Range is going to be maximum minus minimum, biggest minus smallest. In here, 18 minus 15. There's only a 3-year age range in here, but it's a high school. That should be about right. If you got someone in the room who's 20 and someone in the room who's 14, something's wrong. Okay. But then that's also why my smartboard is named Frank. So he was 19 when he dropped out. Range. What else? Standard deviation. Do we really want to take our entire list of ages, all 17 data points, and go find my standard deviation, or look harder at this list? Little sigma with a hairdo. That little O with a curly Q in front, that is lowercase sigma. Because they're Greek. Your standard deviation is approximately 0.844. That's how we're going to find our standard deviation. We are never going to do that by hand again. You're never going to do any of these stats by hand again. You're just going to type, stat, calculate, answer. Cool? So now, let's find out who in the room is abnormal.
Oh, cool. From all those values, I'd be the most abnormal, right? Because I was.
Just go over here again, cross out theirs. I don't care about theirs. We're going to do our own stuff. What would be something that we can compare in here? Kids get weird if you say weight. Height, shoe size. Number of siblings is always a fun one. Shoe size is fun because that's when we find out like who's got little peg legs and who's got water skis.
I seriously don't even know my shoes.
But look at them.
It's right there.
It's right on it.
On the tongue.
What do you want to do?
I'm guessing
Shoe size? All right. Let's see who's got the big clompers and who's got little bitty boots.
Were you doing men's size, European size?
Destroy the patriarchy. We're going to have all the guys subtract 1.5 from yours. We're going with lady sizes. Destroy the patriarchy. Okay.
I shop for men's 8.5, men's 9.
Okay. It is 1.5, right?
It is 1.5, but the thing is that women's sizes, when they get to the higher sizes, they lie to you. So I would be like a men's 8.5, but like I'm a woman's 11.5.
It's only supposed to be 1.5 between them.
They're
Someone
liars.
Google.
They all lie. It's 1.542.
I just realized I bought the shoe in Korea.
Because
I
men-
don't have the proper shoes.
Because those are going to be on metric sizes, right? By centimeters?
Yeah. 280.
Yeah. Oh, yours is by millimeters. Holy crap. Okay.
You're an 11 woman.
1.5. That's what I thought. Okay, so if you are wearing men's size shoes, subtract 1.5 from the size. We're going to go with the lady sizes. Okay? Stat. Edit. Over to list 2. I want you to know how to switch your lists. Go over to list 2 and we're going to go around the room. Shoe size. Lori. 7. 7. Sammy. 8.
11.
Would you say mine was?
It's probably an 11 and a half.
Okay, 11.5. Oh, 11.5. There we go. 7.5. 9.
There's so many feet today.
Someone in this room is secretly getting way too excited. 8. 8. Also an 8. Okay. Levi?
8.
8.
All right.
Why is so many 8s?
I think I got 10.5.
Did you already give your value?
And that's subtracting the 1.5.
Yeah.
Okay. Okay.
We're on. Okay.
16. Wait, no, 16.
So that's 10.5.
Be- 7.5 and okay, 10. And just to keep it an even number, I'll hop in there. What is that? 9.5.
Largest shoes.
How do I have a largest shoe size?
I have one.
I got
Yeah.
I was 0 on that one.
I got
Right
the
there.
smallest shoe in my
Oh, don't ever do that because that's going to say the person is 0 years old.
Yeah, how do I get rid of it?
Delete.
That's it.
Oh,
Did you have that
Okay.
same?
All right.
Oh yeah.
Right. What are your measures of central tendency and spread? Write your measures of central tendency and spread for shoe sizes in the room.
Wait, how do I switch which one it does?
I want you to sniff around on that calculator. How are you going to switch over to list 2 instead of list 1?
Because I.
Same thing. Right after this, you're going to hit second list 2. And it just tells it to use that one instead. There you go. This wasn't as drastic as I thought it was going to be. When I did this last year, I had someone in the room who had size, I kid you not, 3, size 3 women's. And we had one of the guys, even after the reduction, was at a 13.5. It might have been. Mm-hmm.
Small feet. Oh. Runner or track sub.
Okay, write out your measures of central tendency and spread for our feet.
Did I give 11.5 or did I give 11? What was the 11.5? Oh, right.
Sorry. Is that a stereotype that I don't know about?
Possibly.
Okay, did you find how to switch it over? Go stat, calculate, one variable stats, and to switch it over above 1, 2, 3, 4, 5, 6 are the different lists. So I'll say second list 2 instead. Second 3. Above 1, 2, 3, 4, 5, and 6 are your different lists. Okay? And it says on average, got an 8.5, which sounded about right. I heard an awful lot of 8s, and then we had a couple of not water skis, but just bigger. You got your standard deviation, 1.3 something, 18 people, and that 5-number summary.
Yeah, I can't read.
Range is maximum minus minimum, right? So 11.5 minus 6.5. 5 whole shoe sizes. Well, 10 because you have the halves, but okay. Because people tie their self-esteem and personal worth to physical measurement. Female expectations of being small and dainty and petite so that you can be controlled and all that kind of stuff. Guys overcompensating, hick trucks, right? So that's all it is, right? Let's be honest. That lift kit is just a modern day codpiece. So, now, as I'm doing all of this data stuff, this is just how I find the raw numbers. Things that I can do with it, the 2 types of graphs that we may or may not have seen. 1, box and whisker plots. Do you remember what they are and how to find them? Okay, everyone got the same data, right? You compared with your neighbors, you're all good? Okay. Go forward 2 pages. Okay, we'll come back to this, I hope. Or 2 slides, whatever. To this, box and whisker plot. Okay? And we're going to cross this out and we're going to say feet. Okay? Because we already have a data set to work with, right? A box and whisker plot says the median is in the middle. Minimum and maximum, we already know those. What are these things called? Not quadratics. Quartiles. Okay, yeah, I had something with a claw in there. Okay, they are quartiles. Quartiles are super easy to find. They're the median of each half. So you cut the data set in half and then you find the median of each half. What's important to note about that, because they're quartiles, you're looking at 25% of your data in each section, that doesn't mean the graph is going to be evenly spaced like that. You might have a box and whisker plot that looks like this. Why would it look like that? Maybe it's like there's a crap ton of people that are age 15 through 18 and then there's a 38-year-old in the room. Okay, it's an outlier. 25% of my data is here. In fact, if we did this for ages, I bet ours would look like this. You wouldn't even have a tail at the end because so much of my data is compacted in one area. And that is possible. We have to recognize there's still 25% there. So we are going to make our box and whisker plot down here by that 5-number summary. The 5-number summary is minimum quartile 1, median quartile 3, maximum. Easy peasy, right? So down in that area next to that box, you're going to put a number line. We're going to want enough spacing for 6.5 through 11.5. So maybe I'll call this 6, 7, 8, 9, 10, 11, 12. Super easy to make these. You're going to have whisker 1 over here at 6.5. And we're going to label 6.5 and we're going to say this is the minimum. The beginning of the box is at 7.5. So I'm going to say this is quartile 1, quartile 1, 7.5. My median was at 8. So I got my 8 here. I'm going to say median. Quartile 3 was 9.5. And I'll connect the box. And then maximum 11.5. And then I'll extend those whiskers. You ever see a car that has curb feelers on it? It looks like whiskers on their wheels. It's like an old thing from the 70s and before where they would have these like almost like coat hanger needle looking things coming off of the wheels so that when they pulled up next to the curb, they'd hear that of it scraping along the curb. That's what whiskers are on animals. They're like little sticks out there to tell them whether they're close to an object or not when they hit it. Okay, so this is how you make a box and whisker plot. Turns out there's an app for that. Well, not an app, but
I'm sure there is.
second, right above y equals a stat plot. This is also why I wanted you to put list 1 and list 2. Because if I turn both plots on, I can now look at the feet and the ages on the same scale to see which one's which. Okay, so I'm going to say plot 1
Oh, did we do?
is on. What kind of box, what kind of graph am I looking for? So I'm going to go down here and go to box and whisker plot. Notice there's 2 of them. The first one shortens the whiskers up and puts asterisks out here at outliers. The second one is just the normal box and whisker plot. That's the one we're looking for. Okay, so if you ever want to see what outliers are, it'll actually shorten it up for you and show you where they are. So I've got plot 1 is going to be list 1. This is ages. We still have that data in our calculator. I'm going to box and whisker plot for my ages. Arrow up, go to plot 2. Let's turn that one on too. This is shoe sizes. And turn that to a box and whisker plot. Now I want you to see what happens if I go to graph this right now. Zoom to my, remember zoom stat? If I ever put data in, I go zoom stat and they'll just auto size it for me. Why are they the same? I did list 1 on both of them. I need to make sure, and it even says list 1, list 1. I need to make sure that this says the correct thing. I'm going to change that over to list 2. And now zoom stat. And it shows you ages versus shoe sizes. Okay.
Why are yours on
It likes to put whatever the most recent one is on the number line.
Oh, okay. I just wanted
Yeah.
to make sure I was
Okay. So this allows me to start talking about data in terms of consistency or not. Literally, I can see the range of values on here. Which of those 2 data sets was more consistent? Ages, for sure. This was more spread out. Do you see how this quartile was much smaller than either of the next two. It's still 25% of my data. Hit trace. Look at up top, what is it tracing? Now we're on the ages, look at what it's saying down here. Who says you need to make these by hand anymore? Just arrow back and forth and it gives you your 5-number summary. Arrow down to shoe sizes. Arrow back and forth. There's all of your 5-number summary. Okay. This was supposed to be the difference between Algebra 1 and Algebra 2. In Algebra 2, we were supposed to be going through like a whole week and a half of prob stats showing you, no, there's an easier way to do it. Now, what does that mean? Okay, and I know we didn't get to that stuff. Standard deviation. Y'all remember talking about, some of you said that you saw it before. Standard deviation is how you determine who's actually normal in the room and not. Okay, so we made our box and whisker plot, right? I'm not concerned about the frequency tables. So if you got like a blank page after this, or if you want to use this area, whatever, I'm just going to short version what standard deviation normal curve is. So if you just got some space to write somewhere, I mean, we're at the end of the packet, so why not? Put what definitions? No, just cross the whole works out. The frequency tables and all that. It's just tables. Like, that's all it is. Here. Hey. There we go. So, I hope you've seen a normal curve before. No, okay. I got a lot of dorky math t-shirts, right? One of them was a number, was a normal curve like this. That's it. That's the entire t-shirt. And I'd have kids say, does that mean we're at the beginning of the roller coaster? And I'd look at them and say, yup. Because, for example, I was doing something like mean, 1 standard deviation, 2 standard deviations, 3. This is how we make our normal curve. Okay. And it's, y'all, it's so simple. Everything that is in here, everything that's in these two areas represents roughly 68% of the population on a normal curve. If I go further out to like here, this gets me out to 95% of the population in a normal set of data. If I go out to here, this will get me to 99.7% of my data in a normal population. So, say for example, we found out what the mean shoe size was. And my standard deviation was like 1.4 or whatever. Add 1.4, add 1.4, add 1.4. The only people that are actually abnormal are the ones out here. 3 standard deviations or more away. The reason that t-shirt said that is it was talking about IQ. Y'all, anything 70 and below is considered a developmental disability, like cognitively impaired. The t-shirt says, you dumb, to anyone who doesn't understand how to read it. Ha ha ha. Okay, now there are different types of intelligence. Y'all, my social emotional quotients are usually around here, but last time I was assessed, full IQ was over there. I'm smart, I just can't people. Everyone has different skills. But that normal distribution, if that interests you, I know a couple of kids have talked to me about possibly going into education. You will need to know this stuff because this is how you determine criteria for special education, for reading assessments, interventions. If you're looking at anything medical, I know some kids get interested in like psychology, mental health, stuff like that. You got to know this. I'd be more than happy to run through more with you, but that's all we had time for.